All right, now this video is going to cover when we want to convert rectangular coordinates. So what that means is you're in terms of X and Y, and we want to convert them to polar coordinates. So now our inputs are and our outputs theta. All right, well, remember we discussed in that first video is there is something nice about polar coordinates because you can get exactly your location. Whereas if you're looking at A, it's a little challenging because those are irrational numbers and I would have to approximate where I would end up, which polar coordinates could be irrational as well. I should have said irrational. I think I said rational. Okay, so what I'm going to do is actually, I'm going to go out of order. I'm going to do B first. So my coordinate 0, -2. This is polar graph paper here. I can also treat it like a rectangular coordinate system. And 0, -2 would just end up being right here. Well, I want to see how I can represent that with an angle and a radius. This one's kind of nice because I don't really have to do the work because, well, I know my angle, right? Typically, just so you know, we do go between 0 and 2 pi. But you can represent it in another way if you'd like. And that's the other really nice thing about these polar coordinates. And I'll go more into that in a couple of videos, but I know that angle. That angle is just 3 pi over 2. And you know your R. It's just the distance from your origin or the pole. So it's just going to be 2. So my coordinate is 2, 3 pi over 2. I don't have to do any work on those. Now, say you're like, no, Stephanie, I don't get it. Well, first off, we could find our R by doing Pythagorean theorem. And what do you know? We get 2. You can do, to find your theta, which we talked about in that first video, it's inverse tangent of opposite y over adjacent, which is x. This is undefined. We can't divide by 0. But we know from the unit circle that that's 3 pi over 2. And we also know that tangent's undefined at pi over 2 and 3 pi over 2. So you want to think about location too before you decide your angle. All right, look at A. Now A, so I should go ahead and label this. I'm going to label this 0, -2. Now A is saying -√6 and √2. So -√6, I'm going to use my calculator. I'm just going to put a -√6 and I get about -2.45. And √2 is approximately 1.41. So I don't know exactly where this is going to end because I'm going to have to do approximations, but I hope we all can agree that we would be in quadrant 2, right? Because your x's are negative, but your y's are positive. So I need to somehow change this to be r comma theta. Well, if I go and let me go ahead and give us the approximation about -2.45 and 1.4. So again, I'm totally approximating like right here. Oh, no, it's a little bit more actually. 2, about right here. All right, so if you want a visual, if you're like me, remember, you can create a triangle. This is -√6. This is positive √2. And I'm so sorry, I did not put that in the right location again. It's going to be right here. Because it's a little bit more than 1. Well, you can figure out your R using Pythagorean theorem. All right, well, I get 6 plus 2. I do this all the time, forgive me. I write the answer before we find it. So I get r squared equals 8. Take the square root. R, now remember, always simplify it, it's 2 √2. And now I can figure out my angle 2, arc tangent, of opposite over adjacent, which is y over x. I can reduce that. So I'm going to say this is inverse tangent of 2 goes into 6 3 times. Now, if it's on your unit circle, find the exact. Don't use a calculator. So if you gave me a decimal, you'd be marked wrong because this thing is on your calculator. I mean, the unit circle. So if you have this, I'm going to rationalize it. All right. You have to remember where you're located. We're in quadrant 2. So some of us might be inclined to be like, no, theta is negative pi over 6. That's not true because negative pi over 6 would put me in this quadrant. I need to be in the same quadrant as where this is located. Now I know we have drilled into you these restrictions for inverse tangent, all of these restrictions. That is when it's the function itself. We are using inverse tangent to figure out the angle. So it's like a stepping stone. So there aren't any restrictions. It's helping us find the location. So my theta here, because you're in quadrant 2, is 5 pi over 6. So my angle, or sorry, my coordinate is 2 root 2 and 5 pi over 6. And if you were to try to plot that, right, I'd go to my angle first and then go out 2 root 2, I will end up in the same location. That's key. So when you do these conversions between rectangular and polar, make sure you end up where you should end up where you started with. All right, one more. So now I'm negative 0.8 and negative 2.1. Well, hopefully you're okay with that. That would put you in quadrant 3. Important to know. So if I go out negative 0.8, I'm going to get rid of this. I go out negative 0.8 and then down negative 2.1. Again, totally approximating because that's all I can do. Something like right there. Well, we can create a triangle. Why I love this class so much. And I can figure out that r. So r squared equals negative 0.8 squared plus negative 2.1 squared. Now these are decimals. You're gonna have to use a calculator. There's no way you can't. Okay, so it will be clear whenever you're being tested on when you can and when you can't. So if I do my calculator, just save us some time, negative 0.8 squared plus, let me square that thing. Negative 2.1, and I'm going to square that thing. Negative 0.8 squared plus negative 2.1 squared. I get 5.05. Take the square root. And we get approximately, so I'm going to use the approximately symbol, 2.25. Now you could ask me and be like, but why is my r positive, right? Because we can't have negatives in polar world. If you make your r negative, which you can be creative and do that, then you got to think about your angle because your angle would be different. So now I need to find inverse tangent of y over x. I definitely cannot do that in my head. I do not have that on the unit circle, so I have to use a calculator. So I'm going to go ahead and bring up Desmos function inverse tangent, and it was negative 2.1 divided by negative 0.8. Now I'm in degrees, which you can be, but let's stick to radians and they'll be clear of what you need to do. I need 1.2068. So let's go ahead and 1.2068, wasn't it? So I'll do 0.7. Let's make sure that's right. 1.207. Yeah, because that 8's after it. Okay, now your calculator, it's programmed to have those restrictions that we talked about with these inverse function. But we want to find location, right? That angle is helping us with direction. So I need to manipulate this a little bit because what this angle is giving me, this puts me in the first quadrant. I don't want the first quadrant. I want that third quadrant. So remember from unit 6, this is kind of cool because it all starts playing together. This is your reference angle. So what that's really, I'm going to just zoom out a little bit more. What that's really telling me is, oh, my calculator is saying go to 1.207 radians. Okay. So I'm totally making an approximation. It's like right here, but I don't want to end up here. I need to go down here. I need an angle that goes from here all the way to here. Well, hopefully this sits well with you. Let's zoom in on this thing a little bit more so it's not. From here to here, isn't that pi units, right? Pi radians, I should say. Your angle is 180 degrees. Well, I need to go pi and then the additional reference angle to get to my true location. So that's why my angle really is, I need to add pi to that. So my polar coordinate is 2.25. And then I'm going to my calculator, 1.207, and I'm going to add pi. So I get 4.348. So I'm going to go ahead and round that to 5. So key thing is, sure, your calculator did all this work for you, which is great, but it's programmed to have those restrictions. So you have to think about where it should be located and how to manipulate it so it gets there. So like a couple things we could talk about before I end this video is if I was in quadrant 2, well, I would do pi minus my reference angle, right? Because that would mean you're coming off of pi that much. If you're in quadrant 4, so here, well, that would be 2 pi take away your reference angle to put you down here. So a lot of like what we did in unit 6.